Hello everyone. Welcome to this webinar on torsion in pre-stress. I'm very happy that you could attend and that you have signed up. My name is Flaviu Popescu. I am a structural engineer, a support and sales engineer at StruSoft in Denmark. Today I will be hosting this webinar together with my colleague, Frederic. Unfortunately, I don't have a picture of him as well, but we will get to him in a later on in the webinar. We are going to use GoToWebinar app to have this presentation. So please, if you have any questions, use the questions field here in the GoToWebinar window. Just type them in and hopefully we can answer them. We can answer all of them. Otherwise, we will get to them when the presentation is finished. Okay, so let's take a look at pre-stress. I will just start PreStress 6.7. And as some users might be already accustomed to it, I am asked to select a standard, a national annex from the list. I'm just going to use standard for now, since we are several countries. And I will enter a name, a length of my element, and choose a section. For this demonstration, I will just use standard Eurocode concrete sections and go through my library and choose this type of section. Let's say 90 by 30. I can see the dimensions here. I can also create my own cross section if I want to. For now, I will just use this. Okay. And I will add it to my project. I am prompted to enter load cases. So I'll just create some load cases. I will create the self-weight of the element. I will have live load. Let's say I'll have the self-weight from the hollow cores, which will come on top of this beam. Okay. I see here that the dead loads will be generated automatically for this type of load case, so that's fine. For this example, I will tick this box, which will create a default fire load combination. So the fire will be considered as well. Let's click OK. And we are now ready to edit the element. I have my element here with this length and its cross section, and I will start putting some reinforcement. I can do that manually using these coordinate systems here, but I also have this layer of reinforcement, which allows me to put my layers of reinforcement automatically and directly. So let's start with, let's say, 4 strands in the bottom of the element and 2 bars at the top. By default, it will just create these pre-tensioned cables in the bottom of the element, and at the top it will have plain reinforcement, standard reinforcement. I can edit these parameters here once I have entered them. Like the pre-stressing force, that diameter even the length and the material. In 6.7, as the theme of this webinar is about, you can also enter torsional reinforcement in this longitudinal reinforcement tab. You have the cross section here, and if I click on place initial reinforcement, it will place some reinforcement for the torsion by default. And I can see that the bars that are marked with red, that is a warning that it overlaps or is in contradiction with my original bending reinforcement, which I've already placed. So if I just click OK now, it will tell me this message. So what I would need to do is edit these covers and distances between my bars so that it won't conflict with my already existing reinforcement. So let's say that I'll place them a little bit below. For the top and for the bottom. Of course, you have to make sure that you are within the region of the torsion reinforcement. So according to the code, you would have a certain area where you would place this torsional reinforcement. You have to make sure that this torsional reinforcement does not go outside of that surface. It looks fine to me right now. So I have placed also the torsional reinforcement using these two buttons. I can move forward to the stirrup reinforcement. And as you might already know, I have this option to automatic design of stirrups. The program PreStress will suggest a layout of stirrups for me. I can check my reinforcement details. Calculation settings. I have the fire settings and my calculation settings, which I'm pretty happy with how they are right now. I don't want to go into any settings right now for that. So I have my element, I have my reinforcement, I also have some torsion reinforcement. Now I go to the loads. Go up here to input loads, and as I have defined it, the self weight is already generated for my stages. So I just need to put the live load. And I'm going to start with the intermediate stage where I'll place it. And the live load, I'll place it, I will make a uniform load, say of 10 kilonewton per meter. And here is where I enter my loads with eccentricity. These loads with eccentricity will actually generate a torsional moment in my calculation. So I enter the eccentricity here, and I have a section reference for the eccentricity. I have the centroid, and I have the left and right and mid-top beam as reference. I will choose to enter it as 0.075 meters from the right edge of my beam. And I will actually go to that section and see what I mean by the right edge. Once I've placed my loads, I can see here my cross section, and I have the right edge, which is here, and I have the eccentricity of 75 millimeters from that right edge, as I can see the arrow pointing. So I have it somewhere around here. So I'm okay with that for now. I have live load, and I will also have the self weight from the hollow cores, which I will define. Again, choosing the uniform load, entering a value. I'll have the same eccentricity from the right side. And I can see now that it made it with the minus, so I have to be really careful that I enter the correct eccentricity with respect to my reference point. I place it for my different stages. And if I go with my mouse cursor to the load, I can also check that my eccentricity is how I want it to be. So I can see that from the edge, it's 0.075 from the right edge. So now if I want to see from the left edge, it'll show me this from the centroid as well. So it's maybe a good idea to check that I have placed the loads with the right eccentricity and the eccentricity that I want. I can get also an overview of my loads and make sure that I have what I want. And I'm ready to go to input my load combinations. I have my release stage where I just consider the self weight, as well as for the storage and maturing transport. For the erection, I will add the self weight of the beam and the self weight of the hollow cores. Then I have the intermediate stage short term, which I will have the self weight of the beam with the live load, but I'll just consider 0.7 for the live load, and then add the self weight of the hollow core. And then make sure I hit change. For the final stage, long term, I'll just copy this equation and just change it to 0.5 for my live load and hit change. For my short term, I switch it back to 0.7. And then I have it for my final stage. I will have 1.35 times 0.0 times my self weight of the beam and the hollow cores self weight, and then 1.5 times 0.7 for my live load, and make sure I change it. For my final stage 6.10b combination, I'll just copy this. I'll enter a 0.5 coefficient for my self weight and then have 1.5 for my live load. And for the fire, I will have this one. Of course, this is my setup. This is what I want to see, and the coefficients of my load cases. It's up to you to have the combination to describe the scenario which you want to have. But for now, I will leave it like this. So right now I have the element defined with its reinforcement, its loads, the load combination, so I'm ready to perform a calculation. Just to remind you that if you have any questions, please use the questions tab here in the GoToWebinar window, and we will try to answer the questions. So let's just perform a calculation. I go to Calculate Analysis. Please be aware of this warning message, which reminds you to make sure that the spaces between the bars respect the requirements. I have here, I've not done that, so I get this warning message. It is up to you to make sure that the distance between the bars respects the requirements. So I'm just going to hit continue for now and make the calculation as it is. And I have my results as internal forces on the element for all of my construction stages. I can take a look at the moment. I can see the torsional moment, shear force, and I can see the deflection as well. So I have my results here according to the calculation that I've performed. I'll take a look at the design and perform a code control. For those of you who are already using PreStress, this is how the process of PreStress goes. So you define your reinforcement, your loads, and you perform a calculation according to that setup, and then perform a code check. This is the basic process of a PreStress project. And I can check my code verifications. I can also take a look. So right after the code check, I see this graphic representation of my utilization for all of the load combinations. So I can see that it's pretty much okay. I have a lot of green, which is good. So I also have some areas where there is red. I can go to my code check results and see this utilizations. I can see that intermediate stage is a bit high utilization. My final stages and my ultimate limit states combinations, as I can see the capacity, the moment capacity is exceeded. And the torsion compression check longitudinal is exceeded. The rest of my calculations, which I can see here, and verifications are okay. So I need to take care of these calculations which do not meet my expectations. So the easiest way for my example is to go to input geometry. And since I want to increase my capacity, I will just add another layer of oops, I've just copied and made PreStress not go my way. I wanted to add another layer so the capacity would be met. Let me see if I have a project here so I don't have to start from the beginning. Yes, this should be good. So it's really important to save your work when you work in when you work with anything really. So I have this. I hope I have some results here. Maybe not. Maybe I'd have to do the calculation again. Or no, I have them here. So let's see. Let's just see the results here. Basically, this is what I want to get in the end. I want to get a good utilization, so all my verifications check out. Once I'm happy with my results, I can just use this printout and generate a report. I can, for my fire settings per section, I can choose to show the table for reduction of reinforcement parameters for my sections. I don't know if I don't choose anything for now, but you can do that. It's basically for the fire settings. I haven't really used it for fire, but you can do that. Okay, so I have the report for my documentation ready to print. With my results for all of my sections and my load combinations, the calculation for fire, my moment, my shear capacity, and the stirrup design, which PreStress suggests. So I've done this calculation. I've seen how I define my reinforcement, my bending reinforcement, my torsion reinforcement, define my loads with eccentricity, and perform a calculation and a code check for a beam. Right now, I can see that there are no questions so far, but please, if you have any questions, write them here. Right now, I'm going to allow my colleague Frederick to take over, and he has a small presentation himself. So I'll just make him a presenter.
Thank you, Flaviu.
Thank you, Frederick.
I will just have a short presentation of the torsion of hollow core elements with regards to EN 1168. So EN 1168 is the product standard of the hollow cores, and there it is stated that the effect of the torsion should be reduced from the capacity of the shear of the hollow cores. And this is basically what we are doing in PreStress. And in EN 1168 433224, there is a good explanation of this, and we are just basically taking the TED, which is the torsional moment caused by any loads, and that will be a reduction of the shear capacity. So in this will work in PreStress 6.7 and onwards. And as we saw with the load that Flaviu made for his special flange beam, we enter the eccentricity with regards to the center of gravity. And the shear calculation needs to be according to Eurocode 2. So it's not a valid option to use the EN 1168 if you are looking at the torsion, even though that both the shear and the torsion are presented in EN 1168. So they cannot be combined according to the product standard. And when we look at the results, if we would not have any torsion, this would basically be the shear table. So this is just the normal shear result. And if we have torsion, the program will include the effect of the torsion. And as we can see here, compare the two results, the VRD has been reduced with regards to the torsion, and that is according to the formula that I showed. So it's not just the VRD without torsion minus the TD or TED, which is the torsional effect, but it actually looks at the center of gravity, and at that level, which is like a critical section of the hollow core, and with all the widths of the particular webs of the hollow core, and will make that calculation and the reduction. And from this point, the program will continue to just make a normal shear calculation. So this will be quite important for the hollow cores, especially in the outer facades where the external walls might be placed on the edge of the hollow core. Then for that hollow core, there might be a torsional effect, even though PreStress will not take into account the effect of the fully slab of the hollow core slabs. So yeah, that was my short presentation here. So I will hand over to Flaviu.
Thank you, Frederick. And thank you everyone for signing up and attending this webinar. I hope it covered all of your possible or questions or your interests for this webinar. For those of you who are not using PreStress yet, please give it a try. Go to strusoft.com/products PreStress and click on Get Started Now. Here is where you fill out the information and apply for a trial license, so you can test the PreStress for yourself and see how it will help you on your projects. I'll just have my contacts again here, so please write me an email or give me a call on this phone number, and we can take a look at some questions you might have or see how PreStress can help you. Thank you again for today, and I wish you a great rest of the week. Bye-bye.